All right, now I want to talk about water, the water cycle, and water as an environmental issue. Um, as we talked about in class, of course, most of the water is in the ocean, about 96 or 97%. So a relatively small fraction is fresh water. Of the fresh water, most of it, a good chunk of it, is ice, primarily at the South Pole and the North Pole, Antarctica and the North Pole and Greenland. Um, of the stuff that's not frozen, a lot of it is in the ground. The stuff that's at the surface that's easily accessible, as it says here, is a relatively small proportion um, of the water that's available. So the water that's liquid and easy to get to is a relatively small proportion. So that requires that we often tap into something like groundwater as a source. Um, so when we look at the hydrologic cycle, of course, we have bodies of water, and the biggest being the oceans. Um, Water gets from these surface waters into the atmosphere through the process of evaporation and also through the process of transpiration, or what's sometimes called evapotranspiration, which is when plants lose water from their leaves, which they do on bright sunny days, quite a bit of that water. Um, the water in the air, this water vapor, we know as it's measured through what's called humidity, and through condensation it forms clouds. The droplets get bigger and bigger. And then finally, the droplets can get so big that they come out of the air or from the clouds as precipitation. Um, when that precipitation hits the land, several things can happen. Some of it just flows across the surface, this surface runoff or surface flow. And some infiltrates into the ground and works its way down into the ground. Some is used pretty quickly by plants, which then put a lot of that back into the atmosphere. But some of it gets deeper down to what we call the groundwater, which is layer of rock that is not completely solid but has space in it, and that space fills up with water. Um, we think of groundwater as being in these large masses called aquifers. Um, the depth underground where you find the groundwater is known as the water table, and it can vary a great deal from tens of feet to hundreds of feet down, depending on where you are. Um, Groundwater just doesn't sit there. It moves with the force of gravity, so it basically moves downhill. Um, where it comes out of the ground, we know that as springs. Sometimes springs come out of the side of a hill, for example, and then you'll get a little stream forming. Other times, the spring can feed a lake, so there are such things as spring-fed lakes. Um, all right. Groundwater sits on impervious rock that is relatively solid with no space on top of it. When we dig a well, we're essentially tapping in to that groundwater. And people who live out in the country away from city water will typically have to rely on well water. Um, what drives this whole system is the sun, because the sun heats up the water and causes evaporation. It heats up the air, which causes the air to start moving, basically causes the wind, which then moves the moisture around in the atmosphere from out over bodies of water onto land where it can fall. So the water just has this cycle it goes through. Um, Not worried about this image too much, just shows the amount of water that's moving out of different parts of the country. Freshwater bodies of water, lakes, they can be divided ecologically into different zones. What's the surface that has lots of light is known as the limnetic zone. Because of all the light, you tend to have lots of plankton, phytoplankton in particular, and then a lot of fish. Deeper parts of the lake with lower light levels are the profundal zone. So not as much in terms of photosynthesis going down there. So those food chains and food webs down at the bottom depend a lot on decomposition. That is, there are a lot of decomposers that break down the dead stuff that floats down from above. Um, the littoral zone is the shoreline. That's where it's relatively shallow and you have vegetation growing up out of the water, things like cattails. Um, Now, it's a little hard to see here, but you can see you can have lakes that are known as oligotrophic lakes and ones that are known as eutrophic lakes. They all have limnetic zones and profundal zones and littoral zones, but eutrophic lakes tend to be older lakes with more of a sand or muddy bottom. They tend to have a lot more nutrients in them, a lot higher plant productivity. Oligotrophic lakes tend to be younger lakes, ones that you find further north with rocky bottoms, clearer water, lower nutrient levels. Um, Eutrophic lakes tend to be found further south, and the reason you find older lakes further south is because down south the ice age has had less of an impact, and up north in places like Wisconsin and Michigan and Minnesota, they were covered with ice back, 12, 15,000 years ago, and so those lakes are relatively young because of that. Um, a phenomenon we see in lakes is what's known as thermal stratification, where in the summertime, the surface gets nice and warm because of all the sunlight, and then that warm water just kind of sits on top of the colder water below. The transition between them is known as the thermocline, and so at the peak of summer, there's really very little mixing between these layers. But in and so the surface where you have lots of the warm water, upper layer is known as the epilimnion. The deeper, colder water is known as the hypolimnion. And you should notice at the peak of summer, you tend to have lots of oxygen at the surface, but much less deeper down. Um, that's because of the lack of mixing. Of course, the oxygen is out here in the air, and as that surface water is agitated, oxygen gets into it, but it really doesn't make its way down to the depths of the lake. All right, now in fall and spring, you get what's known as the turnover. Oops, wrong way, turnover. And so what happens is as fall approaches and it gets colder and colder, the surface gets colder until finally the temperature of the surface is about the same as deeper down, and the lake will mix on a nice windy day. So the bottom water comes to the top and the surface water goes down to the bottom. You get an equilibration of temperature for the most part, and also because of the mixing, oxygen is distributed throughout the lake. Now, if you're far enough north, of course, the top can get even colder and freeze, and you'll get ice forming on the top of your lake. That doesn't happen down here, but in, again, more northern states up in Canada, it does. All right, but then the next summer, the surface will warm up, and it will again stratify with the surface being warmer. And then those high oxygen levels that were at the depths decrease because of all that decomposition that's going on. The decomposers use up the oxygen, and again, more is not being mixed into those deep waters in the summertime. All right, so in addition to lakes and ponds, of course, we have things we know as wetlands, which are land that is wet, sometimes throughout the year, sometimes just part of the year. What good are wetlands? Well, they are natural sponges. They soak up excess water. So during flooding periods, the water that spills out of the river basically spreads out into the floodplain, the wetland, and that means there's less water heading downstream. We'll talk later about how we can impact that system, basically removing wetlands, and it can make flooding worse downstream because the water gets there faster. It's not being soaked up by these wetlands. As that water sits in those wetlands, it has time to soak into the ground and it adds to the groundwater. As water flows through wetlands, it's filtered by the microbes and plants that are there. They sort of take nutrients and excess things out of the water to clean it up. Wetlands are very productive with lots of wildlife. That's where the duck hunters go, of course. And in coastal areas, coastal wetlands buffer the effect of tropical storms. That is, they tend to absorb that water, that storm surge that's being pushed up on the land. Um, just some examples: swamps. Swamps are wetlands that are dominated by trees, like these bald cypress trees, a common wetland tree around or in the United States and down in the South. A bog is one that you tend to find further north, dominated by evergreen trees, and that makes the soils and the water there somewhat acidic. Again, a bog up in Minnesota. Prairie potholes, these are low areas, depressions in an otherwise flat landscape where the water tends to accumulate and forms sometimes ponds that are there throughout the year or parts of the year. Um, Very beneficial for wildlife, of course, again, as a source of water and for ducks and other waterfowl. Um, they're areas that traditionally farmers have not always seen as of value and may have even drained them in the past, but more recently they are definitely seen as valuable and are being preserved or even regenerated, recreated. Um, Yellowstone, a fen. A fen is a wetland dominated by grass, a freshwater wetland dominated by grass-like plants, not really trees so much. A salt marsh, coastal salt marsh is a wetland at the coast dominated by grass-like plants, sedges and such. Um, and so if you go throughout, if you go to coastal areas throughout the world, you'll find these, the East Coast, a lot of these, think of the Georgia, the Carolinas, there's a lot of salt marshes there on the coast, if you've ever been there. Um, Down south we have the Everglades, a large wetland there. And also in more southern areas, southern tip of Florida, tropical areas, mangroves are a common coastal uh, system where they're dominated by these plants known as mangroves, these shrubby trees that grow up out of the salt water, which is a little unusual. Plants typically can't handle salt water, but coastal ones can, and these mangroves in particular can handle growing in really salty conditions. So, of course, as we've said, the ocean covers a great deal of the Earth's surface. It's relatively salty compared to fresh water, although not nearly as salty as some other bodies of water like the Great Salt Lake or the Dead Sea, which Dead Sea you can see is really salty. These bodies of water are too salty for most organisms, and they do not have an incredible diversity of life in them because of that high salt. Mostly a lot of bacteria that can handle these salty conditions. You won't find plants growing in those kinds of conditions, and fish as well really can't handle those conditions. As a resource, of course, oceans are very important for the fish that we can catch out of them. A lot of countries and societies depend on fish as their main source of protein. Of course, as the human population has grown, the amount of fish we catch has increased, putting stress on those systems. Sometimes particular species of fish can be overfished and their numbers can decrease a significant amount. That has led to an increase, this red line here, of what we call aquaculture, or fish farming, basically, um, where you basically raise fish in enclosed areas, whether it's a freshwater pond that you raise catfish in, or at the coast you have these pens, these nets that are out in the water where you raise salmon. So farm-raised salmon are raised in the ocean, but in these pens, these nets. Um, so it's an efficient way to produce the fish, to get them to grow and be in a size you can harvest them. But there are some downsides. Of course, you have to feed those fish, which requires basically catching other fish and grinding them up into like pellets that they can eat. Um, those fish then, of course, poop a lot, and they create wastes that accumulate basically at levels that they would not normally accumulate, because normally those fish are swimming all over the place and their waste would be distributed over a wide area, but now they're distributed in a very small space. Sometimes those fish can escape, and that's a concern if these fish have been bred in particular ways, and there's even some genetically modified ones. And of course, your nets will attract predators who want to try to get at your fish. Um, and when you're growing those fish in high concentrations like that, you'll tend to get disease outbreaks that you have to treat with certain medications. All right, we'll pick up the rest in another video.